And our next speaker is from the other side of the world, the other side of the country too, actually in some sense of the word. Steve Pullins is a self-described techno-geek, as he described. He has more than 35 years of utility experience in operations, maintenance, engineering, and renewables project development. He previously led the nation's modern grid strategy for DOE's NETL. He's worked in more than 20 utilities in smart grid technologies and strategies. He is now the Vice President of Microgrid Solutions at the Hitachi Social Innovation Business Energy Group. And he was past chair of the IEEE Intelligent Grid Coordinating Committee. He's a member of the Transactive Energy Association, member of the World Alliance for Decentralized Energy. He has advised several international utility companies on smart grid technologies, and he has a bachelor's and master's in engineering. He lives in Tennessee, and we'd like to welcome him here from sunny Tennessee. The weather's a little warmer than here.
Good morning. I really appreciate what Dr. Junjawala brought. It's because it's an indication of the kind of thinking that's necessary for the future, which is to not be constrained by our past and what we've been thinking about, but what is possible and what can we do in a different way and bring different key learnings to the table to think about things differently. I want to talk about three things. First, I'm going to talk about a very important event in Hitachi's life in 2010 when it created its next 100-year plan, and that's where the birth of social innovation within our large company came about. Second thing is I'm going to talk a little bit more about technology, some of the technology things shifts that we're seeing. And it's because I can't help myself. I have to. It's technology. And then the third thing, I'm going to give you a personal example of something that we were working on for, and this is in a prior life to Hitachi, working on how do you change the game with refugee communities and utilizing DC and where DC came into being in that space. But first, let's take a look at Hitachi. Hitachi is a large, $94 billion company, 330,000 employees, 100-year-old in 2010, and the leadership decided that what's in store for the next 100 years. So developed a long-term plan. 100 years is a long-term plan. Not 2-year or 3-year, but 100 years. And that kind of thinking changes things. So here you have a very technology-oriented company, hundreds of thousands of engineers, and what came out of that was a vision that it needs to be that the future of the company is all about social innovation. And what that is taking a look at how the cross-section of information technology and basically infrastructure-type systems need to marry to be able to address the world's most pressing social issues. Okay, so that's it's a driving force within our company. The organization that I'm in, working strictly on microgrids, is part of the lead business unit throughout all of Hitachi. It's called Social Innovation Business Unit. So we're part of that, and we live this every day. So I think it's really important to see a large company like this take this step, recognizing that the job one is social innovation, and that the profits and the perspectives will flow from that. So microgrids are a social innovation, and for a lot of different reasons, we do ascribe to the Department of Energy's a microgrid exchange group definition of what a microgrid is, and it's a group of interconnected loads and distributed energy resources in an electrically defined area that you can control as a unit, and you can take it off grid, on grid, at will or at decision. There's a lot of things that goes on in that, and you're actively managing that solution. So that's the framework of our thinking around the transformation of the energy space that is going to achieve social innovation. We believe that microgrids are one of the cornerstones of that radical or evolutionary change that needs to happen within not only developed nations but also developing nations. And as Ashok was saying, you know, there are hundreds of thousands and millions of homes out there across the entire world where a little bit of energy makes sense, and it is transformational. So we ascribe to that as well. So just a little bit, you know, the argument's been going, AC/DC's been going on for a long time, but I think it was pretty interesting, and many of you know that argument between Tesla and Edison. But I think it's really important to take a look at the last bullet here is that for the Chicago World's Fair, you know, Edison was proposing a DC solution to power the World's Fair, and Tesla was proposing an AC solution, and the low bidder won. Okay, so our last 130 years have been shaped by the low bidder. Okay, so what that means is that many of the things I'm going to be talking about the result of that from a home perspective and a business perspective and an energy efficiency and an energy losses perspective, like Ashok was talking about, are based on a low-cost win back in 1883. Okay, so last summer I hosted and sponsored and organized a DC and the AC World super session at the IEEE Power and Energy Society, which is a large organization. You know, there's 400,000 members in IEEE, and there's, I don't know, 100,000 members, I think, in Power and Energy Society, something like that. So it's a large, that's really a techno-geek thing. But here's the speakers that we had associated with that session, and I think you can see that just looking at the titles and who's presenting this, it's not only it's not a U.S. thing, it's a worldwide thing. It's not a global utility bulk power energy thing. It's also a home thing. So the concept of where we bring DC into the space is into an AC world is really horizontal and vertical. So a little bit out of this is that in the United States alone, there's about 70 terawatt hours of losses in the homes alone. So what's that? What's 70? Let's put that into context. What is 70 terawatt hours? How do you think about that? Does anybody know? So it's about 8,500 megawatts for, you know, used for a typical year. So does that help put it into context? So think of that as 8.5 nuke plants. Okay, so and that's just in home losses. All right. Did I hear a wow? Okay, great. That's what I was going for. Okay. So the other thing is that we have to recognize that it's not a greenfield situation. All right, it's a brownfield situation. Because 85, this is again looking at where we are actually in the world, 85% of the buildings that are going to be around, you know, at many of the transformational time frames, 2030, 2040, etc., 85% of those buildings are already here. Okay, so if you're going to make a substantial change in the way we look at energy, you have to recognize that it has to be an inbuilt solution that really drives a lot of that discussion. It's not going to be a greenfield situation. Okay, so that means that we have to develop standards, like Shree's working on, in P2030.10. He's going to talk about that. But we have to be able to recognize that any of these standards really have to provide or drive opportunity for transformation. They can't just be where many standards have been developed in the past, where they're pretty much protection of the status quo. We have to get outside that and kind of move into a standards approach that actually drives or facilitates change and innovation. So the standards themselves have to provide an opportunity for transformation. Okay, does that make sense? All right. So that's a very important thing. So, 43 DC, putting DC in the home is can drive out 43% of those AC losses. And I love, Ashok, I love your examples because I think this data from Doug Hausman just aligns with that very, very well. From Iqbal Hussain, who's the Center Director for Freedom Systems Center at NC State. It's a multi-university collaborative solution. It has 55 industrial partners in that overall National Science Foundation work. One of the key things they're working on, which is a transformational technology, it's called the solid state transformer. Some of you may participate in works like that. NC State and that group of 6 universities is not the only place working on solid state transformers, but it's the one I know. And I think it's really interesting. This is, they've got 3 generations of that developed. The first one was pretty much small scale and could be applicable to a single building or a single home type framework. Now, in their generation 3, that solid state transformer is 15 kV class scale. So it's really something that you could replace out on the pole that sits out in your neighborhood. Now, what's the key to this? The key to this is it's an AC and a DC transformer. So the idea is you can now support or facilitate things like community solar, where maybe one homeowner can't really afford to do a solar project, but collectively you may have 10 or 20 citizens or families get together and develop a community solar project, and you can plug that into the local distribution transformer because it can handle 380 volt DC, and now you've got the ability to utilize that power across. And you've driven out, because it's a solid state transformer, you don't have other inverters, everything, so you've really started to reduce the equipment need and therefore the cost of that kind of solution. So, along with that kind of thing, I don't know how many of you are aware of some of the projects that are going on in New York under the Reforming the Energy Vision, New York REV. Anybody heard about that? Okay. So there's a whole community solar program in New York that enables and subsidizes and helps incentivize communities going out and doing just what I described. This kind of technology helps make that transformation possible. Emerge Alliance, and Paul Savage, who's the CEO of Next Power, and he's also a board member at the Emerge Alliance, presented this. And I think what's really important are the 8 things in green down here, and where DC really starts to help the transformation of the energy industry, in that it greatly enables zero energy or zero net energy buildings, automated demand response, using buildings as a robot, powering the IoT world, just a lot of things where the DC could be transformational in our space. And I go back to thinking about that, that low-cost bid win back in the 1880s. I think it's also really interesting to take a look at where we are today with the barrel of oil being low and gas prices, natural gas prices being low, and how this last statement may actually be true. It could be that electrons are the things that drive the currencies and the capital of the world in the future, not so much based on oil or other fossils. Another example out of the Emerge Alliance, Walgreens has a net zero store that's built completely on DC. Did it as an experiment, but it's an interesting thing. And Walgreens has almost 8,000 stores in the United States, and recently bought Rite Aid, so that adds another 2,500 stores. So when you start to see retail change, looking at things like this as a transformational technology, and why are they doing it? They're not necessarily doing it to be green, okay? They are absolutely driven by the bottom line, okay? But when the bottom line aligns with your green objectives, and in this case, with your resiliency and your reliability objectives, isn't that kind of nice? Another thing in Detroit, the Chrysler House, which I think is a great example of the comparison. If you take a look at the 14th, 15th, and 16th floors of the Chrysler House in Detroit, there's an ongoing experiment looking at the differences between an AC, an AC world, floor 14, a hybrid world, floor 15, AC and DC, and then a DC world, and that's floor 16. And what you see is a substantial change in the energy usage on between those three floors. So in the lower left, you see it's an ongoing dashboard, and the last day kilowatt-hour usage was substantially lower on the 16th floor than the 15th and the 14th. And the reason this is kind of important because the functions, what's going on job-wise and utilization-wise in those three floors is exactly the same. It's a perfect experiment showing the comparison of the three. A friend of mine, Pavel Bauer at Delft University of Technology in the Netherlands, he's a tireless advocate for DC microgrids. And he made a recent presentation. I just pulled one of his slides, where you're taking a look at where does DC play in the world, and where are we seeing that emergence. And what we see is that DC has been around for a long time in the high voltage world, where we're trying to get large amounts of energy moved from one place to another. When you're going over long distances, more than 500 kilometers and things like that, DC is a much more efficient method for transferring bulk power from point A to point B than AC. So there's always been an application there. And whenever I'm going undersea cables, if I've got to go more than about 15 kilometers, I have to shift from AC to DC to be able to do that cost effectively and more safely. So there's always been that kind of world. But what we see now is as we are moving more and more mass transit into the picture, to, basically to drive carbon footprint down, we're seeing that DC is has a much greater role in that transformation of the transportation sector for public transportation. So we're seeing a lot more move in that direction. At least that's a bit what we see in Japan and what we see in Europe as well. And then obviously at the edge of the grid, where we're talking about homes and communities and buildings and commercial parks and things like that, we're starting to see hybridization of those solutions between AC and DC, and then ultimately DC. So these are things that we're seeing worldwide. Bartosz Wojcicki, who is the CEO of Decision Point Global, he's also an adjunct professor at the University of North Carolina. He's one of those guys who as a techno geek, I look to him. His level of techno and geekiness is far superior to mine, and he's one of the things that he's working on with his company, who fund technology startups, are looking at remote communities and the household level movement of DC low voltage solutions. So they're very much consistent with what Ashok was talking about. So I think what we're seeing is that from the U.S., from Europe, from points around the globe, there's really a drive there. It's not a mature technology or mature technology space yet. even though it was there in the beginning when it lost that low bid award. But it is part of our future. Now I want to talk a little bit about something that I worked on. There was we had a need that came up partially out of the State Department, but also from a couple governments in sub-Saharan Africa, because there's a substantial refugee challenge in those areas where you get people or refugees from one country moving into another country, and the cultures clash and things like that. So very much tent cities and things like that. But these tent cities take on the life of, some of them have been around, more than 20 years, and they're not great situations. So we were asked to develop a microgrid community that could, in essence, support a refugee operation, and then also consider taking that concept back into a place like Somalia, where warlords govern. And the idea was, if you could develop a community that's self-sustaining from an energy and a water and a food perspective, then you can diminish the power, the eco-social power of warlords, especially if you had to have the ability to turn it off and keep it turned off if they overran the place, that kind of thing. So now you basically take away the motivation for them to leverage this asset against the population itself. So that's the backdrop of what we were looking at. Now, so this is the community, and what you see is a central hub type of picture with the housing around the edges. So okay, now think back. What does that really look like historically? Did I hear somebody say a castle?
Yeah.
Yeah.
Medieval.
So it looks medieval, doesn't it? Where I've got the protected central core, and then I have all of the serfs and farmers and things like that living around it. Well, maybe that's okay, right? If there's a way and a methodology for pulling people into, when needed, into a protected environment. So here's what it looks like. So you see the pods of homes around, so their own little community, and now that's important. So these little pods of homes, because you have differences in ethnicities, and in these refugee communities, and you have differences in tribes and things like that. So it's important for people to establish their sense of community, but then belong to the larger community, right? And if necessary, then they have the opportunity to go in, and look, it's double walled, okay, very medieval. But the idea is you can get into the central core, and the central core of things, everybody can survive in there for as long as really necessary. Okay, so a little bit closer look. So so every one of these homes was designed to be DC. Okay, now in the central core, mix of AC and DC. But each of these little blocks of homes are DC, a central courtyard for cooking, and which was a cultural expectation. We didn't originally have that designed in, but the feedback from the communities was, you need to have a central place where cooking takes place, because it's cultural. All right. But here's the home. You can't hardly see it, but it's the three L-shaped blocks. Okay, so that's a prefab. We actually did one of these, and the idea was could we make these are 12-foot by 12-foot blocks, so 3 of those, so it's about a little less than 500 square feet total home, in 3 rooms, one in the kitchen and then kind of 2 living areas, but with a PV, energy storage, charge controller, and that kind of thing. So the biggest issue that we found in doing this development was cooking on a stove. The thing that killed everything was cooking on a stove. So we got it down to where you could use, the only thing we could survive with on here was a single burner hot plate. That's the only form of cooking that could actually work within the energy envelope in that. So that's an area of technology that needs to be solved. And I was really interested on the water stove that Ashok put up, because that's the biggest issue for being able to do a truly off-grid DC-based home, how do you manage the cooking, all right? Because you don't want these people reverting to sticking a kerosene burner in the middle of the floor in this home and you know and cooking, because it's a captured carcinogenic environment then, right? That's what you're trying to get away from in these cultures. So that's what. So that's kind of what we had been doing. Have we built that? No. Here's the other issue in sub-Saharan Africa. You know, there's people who you know, try to leverage things, and you end up having a large coal plant built instead by the government, or which really doesn't support any of the refugee camps. Or you have roads being built instead of powering things for the individual communities or vulnerable populations. Eventually, that kind of thing will take place. The World Bank was involved and is involved. So, but it's not being built today. Okay. So, in conclusion, I think what we're seeing is the role of DC in our energy life is increasing. There's a lot of examples, but it's really not a mature business yet. Okay, you should read "Not a Mature Business Yet," not from an investment strategy, something to stay away from, but from an opportunity space. The list of DC innovative technologies is too short. There need to be many more innovative technologies that can be brought to bear, and then start looking at ways of how you put those together like a recipe, okay, to solve some of these issues. And the energy efficiency gain is huge. It's multiplicative, as we've seen when you start adding up homes who save 43% by going DC, and you get to 70 terawatt hours in a year. And standards are emerging. Emerge Alliance is doing a lot of work. IEEE is doing a lot of work in this space. But it's going to need early adopters to really help drive those new standards and help demonstrate and put them out there. The remote, underserved, and developed world is a place where we're going to see step change from the incorporation of greater amounts of DC into this AC world or this life. But there's going to be, the developed world will learn from this. There's going to be things that emerge as a real leap gain in that developing nation structure that the developed world's going to bring back to the table, and we're going to learn from it. It'll take longer, but I think that's what we're going to see, and I think we're going to see that kind of cycle happen. Okay, thank you.